It is actually nothing but layer 1 and layer 2. Layer 1 and layer 2 is different. We can say some more features are added in the blockchain. Initially, when Bitcoin and Ethereum blockchain was there, that was worked with the layer 1. These are, I think, I can show you some properties of layer 1 and layer 2. Okay, layer 1. In the layer 1, let me see because okay, yeah, Ethereum initially layer 1, layer 2 are okay. I think this layer 1, layer 2 means um, in the Bitcoin and all those things, there is a hard fork and a soft fork is there. Okay, hard fork and soft fork is nothing but when when a change in the protocol or something, initially Bitcoin, no, Bitcoin is currently also using the proof of work consensus algorithm, but Ethereum is previously using proof of work. Then now they are changed to proof of stake. So they have changed the consensus algorithm, some architecture or the protocol they have changed. In order to change something, the protocol or something, actually, you know that Ethereum blockchain and Bitcoin it is a blockchain network. No human is controlling. It is a decentralized one. So how they are changing the protocol? In order to change the protocol, what it is called the technique called hard fork or soft fork. It is nothing but it is something like this. Okay, I can show the. It is something like that. Initially, this was the blockchain network. Initially, this is the blockchain network, and a new block is creating something like this. Okay, this is linked with one block is linked with another. After this block has been created, after this block or this block has been created, they may wish to the blockchain the what we can call okay some forum. Okay, some forum they may think that we can change the blockchain consensus algorithm or something. They have created some particular group or more than 51% of the Ethereum nodes are completely designed that think that we can change the consensus algorithm or something. They will create a new block based on new consonants algorithm. In this link, they are using the proof of work consonants algorithm. In this link, they are creating the proof of stake consonants algorithm. And they are continually creating and adding new blocks over here. And more pupils are adding blocks in this new link rather than adding this link. So there is two links at this point. In this block onwards, there are two branches are starting. This is the one branch and another one is this one. And most of the pupils are adding new blocks to the this link. And this link uses the consonance algorithm proof of stake. So that now and onwards, this chain is longer than this chain. And the long in the Bitcoin blockchain network, longer chain will be considered as the blockchain network, and the shorter chain will be discarded later. This chain will be discarded. So this will be the blockchain network. This will be the blockchain network. So this is how the new fork is happening. New fork is happening. So this is happening in the Ethereum blockchain and the Bitcoin blockchain in order to change something, in order to change some consensus algorithm or something. So this is called layer one, hard fork and the forking system. Okay, this is called a forking system. But now, the situation is something different. In order to change some what it is, not to change something on the blockchain architecture, they can create their own separate blockchain. Something like I think a new blockchain network called Solana is there. Solana. Okay, Solana is another one blockchain network. It is actually a new blockchain. It is derived from Ethereum blockchain. Solana blockchain is there, and Polygon. Polygon is another one. Binance is another one. Polygon. These are the different. Our main Ethereum blockchain is also there. It is our main Ethereum blockchain, but they are creating new versions of blockchain network. They are creating their own blockchain based on Ethereum blockchain. So Solana is one blockchain. Polygon is another blockchain. Binance blockchain is there. These three are the main important blockchain network that work exactly same, similar to this Ethereum blockchain, or it is on top of Ethereum. On top of Ethereum, they are using separate blockchain network, Solana, Polygon, Binance. So the advantage of Solana is that they are using very small gas fees, and Polygon as well, Binance as well. They have the simple gas fees and all those things, and block size may be different, and the speed of execution may be different. So these are the advantages of this type of newly created blockchain network. So these are come under layer 2 blockchain network. Layer 2. The foundation is Ethereum blockchain itself, but in the layer 1, if you want to change something, we have to create a fork or something. But in the layer 2, we can create our own blockchain, something like this. It is a blockchain architecture, something. Solana is one example. In this, gas fee is very, very slow compared to, they are optimizing the gas fees. Okay, Solana is used to, but the Solana is also supported this type of smart contract and all those things. We can write the smart contract in Solidity and deploy on the Solana blockchain. Polygon also it support the everything, because it is the basis this one Ethereum blockchain. Okay, only advantage is that we can the gas fees. Okay, in the main Ethereum blockchain, the gas fee is high, and they are using their own in Solana and all those things. I think they have their own cryptocurrency also there called Matic. Matic is in the Polygon. Okay, in the Polygon, they have created their own token called a Matic token, and every transaction is done with this Matic. So it is an entirely different blockchain, but based on the Ethereum blockchain. On top of the Ethereum blockchain, we are creating different sub blockchains. They have their own prototype architecture and everything. This is called a layer 2. But in the layer 1, if you want to change the protocol or something, it was very difficult. We need to make the fork in Bitcoin, Ethereum, and all those things. So this is how the fork is working. But in the layer 2, these are the different blockchain network. We can create our own sub blockchains with our own cryptocurrency, our own setting gas fees and all those. Okay, this is layer 1 and then layer 2. I am not sure about what is layer 3. Let me check whether layer 3 is there. Okay, layer 3, I think it is a decentralized DeFi applications are coming under layer 3, I think. Okay, we just done the project with Truffle, right, for decentralized application. But there are different applications. Some other tool the companies are using is Hard Hat is another tool. Hard Hat. So hard hat also you can use to compile the smart contract and migrate the smart contract. The syntax and all everything is exactly same as that of the syntax and all those things are very similar. Hard hat is also something like not to it is a blockchain framework actually exactly that like the truffle. Truffle is used to compile and migrate the smart contract on the blockchain. Similarly, you can use the hard hat as well to compile and migrate the smart contract. So truffle is also very nice. Companies are currently using truffle as well as this hard hat too to create a decentralized application. In Polygon, it is nothing. Polygon or any other network, it is nothing. What you need to do is in the Remix ID, you just write the program something like that, and take the MetaMask and change this to Polygon network, Polygon or some other network, and deploy it. Okay, that is the thing. But in order to do the Polygon, I think you need to the currency is something different. It is Matic. Okay, writing the programs in Polygon or Solana is simple because it is the base blockchain is this Ethereum. We can write the smart contract like this, and the only thing is change this network to Solana or Polygon and deploy it. Hyperledger is Hyperledger. We already discussed that there are two types of blockchains are there. One is private and another one is public blockchain. So public blockchain is we already discussed. This is Ethereum and Bitcoin. So what all are the things you are doing? Any transaction doing in the public blockchain like Ethereum blockchain or Bitcoin blockchain? Everything is transparent, completely transparent. It is publicly available. But some companies are not wish to publish their data on the public blockchain. They may use the private, their data should be private. So in order to solve such things, it is introduced a Linux-based open source called Hyperledger. Hyperledger. Okay, Hyperledger. So Hyperledger is a umbrella term. There is different types of Hyperledger projects are there. Hyperledger Fabric is one of the famous one. Hyperledger Fabric, Sawtooth is there, Corda is there. So many different private blockchains are there. It is only the private blockchain. It is only the private blockchain. It may have okay something like this. Okay, it is a private blockchain actually. A hospital. Okay, suppose there a hospital. In a hospital, the patient data and the record are already storing in a database. But suppose a company they want to store their data on a blockchain, and the two companies are combined, joint company come together, two or three. Okay, three hospital. It is called organizations in the blockchain in the Hyperledger Fabric. Okay, so suppose these three organizations come together and they want to create a blockchain network. So they created the blockchain network. They created the blockchain network. It is a private blockchain. No other nodes are participated in this blockchain network. This is private. So here, if they are storing the patient data on the Ethereum blockchain, means anybody can see the data. The data becomes public. If you are using the smart contract and the Ethereum blockchain, means the data will be public. So in order to solve this public or the privacy of the data, they have used this Hyperledger or Hyperledger Fabric or Hyperledger Sawtooth. This is the Hyperledger network. Three organization named organization. This may be the first hospital A. This is the second hospital B, and this may be third hospital C. And if we are creating a blockchain network among the three means, the data will be, it is a common. Okay, this is the Hyperledger Fabric that work on over here. It is the Hyperledger Fabric. The data will be stored over here. And and they can, each company, each organization, they want to share the data among themselves means they can share with the a platform called a channel. They can create a channel in between them and they can share the data among through that channel. Okay, suppose A and B want to share particular data, particular order history or something without the knowledge of C. They can that also possible with this hyperledger fabric. They can create a channel between A and B, and they can communicate with that channel. Normally, these three organizations are participating in the blockchain network so that the patient data will be available. They can share the data among these, and the data will not go beyond these three organizations. The three organizations will be participating in the blockchain network, and the data will not go beyond that organization. This is called a private blockchain. In order to implement the private blockchain, we are using the hyperledger fabric. It is an open platform. So this is hyperledger fabric. And other private blockchains are hyperledger fabric, hyperledger Sawtooth is there, Corda is there, R3 is there. Different private blockchain networks are there. And we can write the programs as well in the form of chain code. We are using the term chain code to write the smart contract on the private blockchains. Okay. Bot is something like, let me check I am having one bot or not. It is nothing but it is a smart contract actually. Or we can write our own JavaScript code as well in order to create a bot. Let me check I am having a bot. Okay, this is one type of bot that I have created. It is for getting the price. Okay, I need to get the price from different decentralized exchanges of a particular okay, well, because I want to do some flash loans and all those things to create the profit. What I have done is, first of all, I need to, okay, it is called arbitration. We can call it as an arbitration. For example, okay, this one. Okay, suppose there is two companies are there, two exchanges are there, decentralized exchange. So first exchange is this one. First exchange is this one. This is the second exchange. Two or three or many exchanges are there. You know, in my program, I have used the two exchanges. So this is first exchange called A. This exchange name is A. That may be a Kyber exchange or DYDX exchange or Aave or any other decentralized exchange. And the second exchange is B. And suppose here in the exchange A, one token or Ethereum. Ethereum is selling with the price $100. Okay, here in exchange A, the Ethereum is selling. Current Ethereum price is $100 over here. So here it is around $101. It is $101. So two exchanges, and there is a small price difference is there. What I am going to do is, okay, it is my smart contract, not a bot. Here I have written a bot. It is my bot. Okay, it is my bot. What my bot is doing is, it is capturing all the prices. It is lively capturing the prices from the exchanges. As you know, the reading from the blockchain is free of cost. You don't need to pay the money. So my bot is continuously watching these exchanges and reading the prices of the currencies. And I got some difference is there for a particular minute or particular time period. I found that this was the situation. This bot found that this is the situation, and there is a price difference is there between these exchanges, this exchange 1 and exchange 2. There is a price difference is there. What the bot is doing is, it is place an buy order. It places a buy order to exchange A. It is a buy order to the exchange A. It will purchase, it will buy one Ethereum from exchange A or the lower range. because exchange A has a lower rate compared to exchange B. So it will place a buy order from the this exchange by paying $100, and he got 1 Ethereum. And at the same time, it executes a sell order to the exchange B at the same time, because it is a bot. It supplies a sell order to exchange B. So it will sell this one, and 100 either the bot is spent, and he received $101. So during this transaction, he got $1 profit. He got a $1 profit. So this is the thing happening. We can do with the bot. Okay, bot. This is the scenario with one Ethereum. What happens if we purchase the same transaction with 1 lakh Ethereum? So his profit is $1 lakh, $1 lakh. What we can purchase 1 lakh Ethereum or 1 lakh Ethereum from this exchange, and at the same time he can sell that 1 lakh Ethereum over here, so that he can make a profit of $1 lakh. So not to pay the 1 lakh Ethereum, you don't think that this much of money you should have to purchase this one. There is another option called flash loan is there. There is a wonderful concept, flash loan. So that you can purchase this Ethereum, or it will be credited. Okay, 1 million or 1 lakh Ethereum will be credited to your account, and you can use this Ethereum, and after using this Ethereum, make a profit or something with this Ethereum, and repay that Ethereum to the pool. Okay, Ethereum pool. Aave is one of the Ethereum pool. They are providing this flash loans. So in the normal scenario, how to get a loan? You need to approach the bank, and so many procedures are there. You need to use that loan amount to make the profit or some other work, and after that you need to return back the loan. The same scenario is happening over here. You can buy a, what happens is, okay, this is the bot. He can borrow a flash loan. He can borrow a flash loan, so that he may get 1,000 or this much of Ethereum. He got this much of Ethereum. This bot got 1,000 of Ethereum, and using this Ethereum, he can purchase this token. Okay, some other token, maybe TRX. Okay, TRX. Suppose TRX is currently okay. This may be not dollar. The TRX is selling over here. TRX token. Suppose this TRX token is purchased. TRX price may be current price may be TRX equal to price may be is equal to approximately one Ethereum. Okay, over here on this exchange, one TRX price equal to 1.2 Ethereum. Okay, there is a price difference is there about 0.2 Ethereum. 0.2 Ethereum. There is a price difference. Assume that this is the price difference. And what you can do, you can buy a TRX coin from this exchange by giving 1 Ethereum. And at the same time, because you found that and there is an arbitration chance is there, because the price difference is there. So give 1 Ethereum and buy 1 TRX and sell this TRX over here, so that you will get 1.2 Ethereum. That means 1 Ethereum you are spending, you are getting by 1.2 Ethereum. So 0.2 Ethereum profit at one transaction. So if you have 10,000 Ethereum in your pocket, you can purchase 10,000 TRX from exchange A, and this 10,000 TRX you can sell over here. You can get around 2,000 Ethereum profit. Okay, around 2,000 or 200. Okay, 2,000 Ethereum. You can get this much of Ethereum profit. 2,000 Ethereum is not a small amount. You can make this much of profit. In order to, you may think that in order to do this one, you need to have this 10,000 Ethereum in your pocket. No need. What you can do is, there is another application, another platform called Flash Loans is there. The bot can borrow the bot can borrow the Ethereum from here. From here. This is a Aave pool or something. Ethereum pool. Okay, flash loan pool. From here, you can borrow the Ethereum and make this transaction. Now you are having 10,000 Ethereum. This bot is having 10,000 Ethereum. This 10,000 Ethereum, using this 10,000 Ethereum, you can do this transaction and make a 2,000 Ethereum profit. Okay, now 2,000 Ethereum profit in your hand, 2,000 Ethereum plus 10,000 Ethereum is there. Originally, you have borrowed 10,000 Ethereum is there. Total 12,000 Ethereum you are having. You have borrowed 10,000 Ethereum, done this transaction, and you will get 12,000 Ethereum. Out of this 12,000 Ethereum, you need to pay by 10,000 Ethereum. Okay, to the borrower. I mean the pool. From here, you borrowed 10,000 Ethereum. You need to return back. That means you have 2,000 Ethereum profit. This is another application of bot by using flash loan. But usually the bot is used to make the profit. Okay, something like this. So here I have created a bot. Okay, it is for finding the price difference. First, you need to find the price difference. Okay, this is the price difference. Okay, this is one bot I have created. First of all, we need to find the price difference. Then only you can do these things. Any price difference between the exchanges. So here, we have used the different exchanges. Yeah, Uniswap is one exchanges I have used, and a Kyber. These are the two decentralized exchanges I have used. So Uniswap exchange is a smart contract. This is the address of Kyber. This is the exchange of Uniswap, and you need to read the price difference. Yeah, monitor price is there. This is the price difference. Okay, I have used only for the price. Okay, price I am reading. Check the price from both the exchanges. If any price difference is found, you can do this type of transactions and make a profit. Okay, that is one bot. That is the use of bots. What you need to do is, as an Ethereum blockchain developer, you can do study the Solidity language. They are mainly using this Solidity language. For the Rust and all those things, I think there is another language called Solana. Okay, we can use the Rust language or those things. It is also there. But Solidity, most of the companies are currently using the Solidity language. You can have a look into the Solidity language and try to write the smart contract. And while writing the smart contract, the security is also one of the issues. Because the problem with the smart contract is that once the smart contract is deployed on the blockchain, you cannot modify it. It is very difficult to modify. Nobody can modify it once it is deployed. So whenever you are writing the program, whenever you are writing the smart contract, it should be error free. Or there should not be any security hole should be there. You need to double check your code before deploying. Writing the there are different types of attacks are there in the smart contract. That is called re-entrancy attack is there. Some other attacks are there. If you are writing the code something like this, means somebody can easily hack your smart contract. So have a look. I will show you what is a re-entrancy attack. That is a very interesting attack. Okay, it is happening in the I think one of the famous in the Open Zeppelin library or something. I think they have found this re-entrancy attack. Okay, I can show you re-entrancy attack is there. Okay, I will show you one smart contract. Re-entrancy attack. Okay, just to familiar with this attack, how it works. Some program is there means we can check. Okay, this we can use this one, this smart contract. Okay, deposit fund. Copy. Okay. So I am using this smart contract. Okay, just have a look into this. Yeah, staking token is another use case of this DeFi application. You can stake the token. You can stake. You if you have 100 Ethereum with you, you can give us stake. You can stake this 100 Ethereum to a pool, and they will give you some profit from that. It may be very better than the bank interest and all this. So many people are using this staking also. They have used in the Binance exchange and all those things. This type of staking is available. Okay. Okay, this is one smart contract. Okay, you just see this smart contract. Contracts deposit. Okay, not to do this one. First line, you need to before the first line should be. Otherwise, there will be an error. Okay. Okay, contracted deposit fund mapping is there. Public balances, deposit, public payable. So this function is used to anybody can deposit fund to the smart contract, and then it is recorded over here. And the withdraw function is there. We are fetching by the balance greater than 0. Okay, if balance greater than 0, the withdraw function can be called by somebody if the balance should be if his balance is greater than 0. Okay, there is okay, then if balance is greater than 0, we are transferring that value to the caller function. Okay, who is calling message dot sender dot call and value equal to value. Okay, this much of value, this much of balance we are transferring to that person. uh, if you have invested some amount in this smart contract, you can call this withdraw function. Then whenever you are calling this withdraw function, this balance, what all the amount you are invested over here, that should be returned back. So this code is used to returning the balance to your account. Okay, require failed to send either. Okay, if any error is there, failed to send. If this value is false, means there is an error. And after that, msg dot sender equal to 0. After that, we have made this msg dot sender equal to 0. This is a smart contract. Okay, while seeing this one, actually this smart contract is a highly vulnerable smart contract. Highly vulnerable. Highly vulnerable because because um, we can create or any attacker. This is a smart contract. This is simply a smart contract. Any attacker can call this smart contract. He can invest this some amount to this smart contract. Some smart contract can deposit, can call this deposit function, and invest some amount. so that smart contract may have some balance. Okay, the smart contract has some balance. After that, he is calling this withdraw function. Suppose this, assume that this deposit fund smart contract, I can first of all I can deploy it. I am going to deploy this smart contract on the where we can deploy. Okay, local blockchain. Okay, I can deposit in the browser local blockchain. Already done. I am going to deploy it. Deposit fund. Okay, it has been deployed. Now you can see here two functions are there. Deposit, withdraw, and okay, balance is nothing but okay, deposit and withdraw. And anybody can deposit a fund to this one. Anybody can. Okay, so the second person, some other person, this person investing, okay, Ethereum. This person invested 10 Ethereum. Okay, okay, this person invested, deposited 10 Ethereum. Okay, he deposited 10 Ethereum, and another person. Okay, this person also invested 15 Ethereum. 15 Ethereum deposit. Okay, 15 Ethereum. So okay, so this is the currently this smart contract hold 25 Ethereum in this account. This Ethereum, this smart contract having 25 Ethereum, because so many publics are depositing the amount over here. Something like a bank, depositing the amount. So one person invested 10 Ethereum and the second person invested 20 Ethereum. So 55, 15 Ethereum or something. So total 25 Ethereum in this account, in this smart contract. 25 Ethereum is there. 25 Ethereum. Okay, let me check. We can have the balance. No. Yeah, here you can see the smart contract having the balance 25 Ethereum. 25 Ethereum. I am okay. Some other person also investing. Okay, this person also investing. The public is going to invest over here. Okay, he is investing 12 Ethereum. Okay, deposit 12 Ethereum. Okay, it is invested. Now you can see total 37 Ethereum in this smart contract. Okay, till now there is malicious over there. Now what I am going to do is, anybody can call this deposit function, right? Because it is public. Anybody can call. Not a person, any smart contract also can call this function. So I am going to write a new smart contract. I am going to write a new smart contract. The smart contract is also given over here. Okay, this is the callback function. Okay, so come over here. I am going to write a new smart contract. Attack dot SOI. I am writing a new smart contract. Okay, the attacker is writing a new smart contract, something like this. Okay, attacker is okay, only warning. Okay, so the attacker is written the smart contract like this: deposit fund, constructed deposit. Uh, okay, we will deposit one fallback function, like external payable if address greater than one is the deposit fund. Okay, fallback function, attack function recur. Original value greater than zero, deposit. Okay, we are calling deposit fund deposit one Ethereum. We are depositing and we are withdrawing. Okay, when we are withdrawing, this fallback function will execute. Okay, fallback function, the withdraw function. Okay, right. So what I am going to do is, this is the attacker smart contract. This is the attacker smart contract. We are going to deploy this one. Okay, we are going to deploy this one. This is the attacker smart contract. Also, I am going to deploy. Okay, attacker smart contract is deployed. Attacker smart contract is getting deployed. Okay, so this is the attacker. See, now anybody can create a smart contract. Anybody can create a smart contract. So already one smart contract is there. This is a deposit fund smart contract is there, and this smart contract having so many people are invested some balance, so many people are invested some Ethereum over there. So total balance is 37 Ethereum over here on this smart contract. Three people are invested over here. 37 Ethereum is there. Now the attacker is creating a smart contract. Attacker is created or a hacker is created this smart contract. And what he is doing is he is first deposit some Ethereum. Okay, he is first to deposit one Ethereum to the smart contract. Okay, so deposit fund. He is depositing. Okay, he is deposited one Ethereum. He deposited one Ethereum. Now the balance of this Ethereum, this smart contract will be 30. Oh, okay, it is not deposited. Depositive attacker is calling depositive function from here. Oh, okay, sorry. Okay, so first of all, what he can do is he need to deposit some amount, otherwise it will not work. Oh, okay, okay, it is calling from here. Okay, what he can do is he is calling the attack function. The attacker, okay, leave with this one. This deposit fund having 37 Ethereum over here, and attacker creating this smart contract, and he is trying to call this function, this function by paying one Ethereum. Okay, one Ethereum is there. He is trying to call. Okay, it is called and see. Oh, okay, it is not worked. Some error has happened. Okay, not to receive the Ethereum, we need to write this code as well. It is because this attacker function don't have any either balance. What we can do is we need to transfer some. That was the problem. This this function should have some balance. Okay, copy this account. How to send Ethereum to this account? We can do the same thing on the Geolly test network. No, Geolly it is not possible. Local blockchain. Okay, let me open the Ganache blockchain and do the same program. I am connecting to local blockchain. Okay, this account is having some Ethereum. This account don't have any Ethereum. Account 6 is having Ethereum. So 50 Ethereum I am transferring to this account 50 Ethereum. I'm transferring 50 Ethereum. Okay, now this account is having 50 Ethereum. It's going to be 50 Ethereum. And this account will be credited to 50 Ethereum. Okay, 50 Ethereum credited. I am having two accounts with some balance. Okay, that's fine. And now what I am going to do is I am deleting these two smart contracts and I am connecting through injectable. What I am going to do is I am going to do this thing on the local blockchain. Okay, it is a local blockchain. First of all, I am going to migrate the deposit fund. Okay, deposit fund. I am going to deploy it. Injected Web3. Okay, it is going to deposit. It is deposited. Okay, it is deposited. Okay, currently the account having no balance, and some people, some persons, he is having balance. He is depositing some amount. He is depositing. He is depositing some Ethereum. Okay, 20 Ethereum he is depositing. That person depositing 20 Ethereum deposit. So 20 Ethereum depositing to the smart contract. So that the smart contract balance is now 20 Ethereum. This person, okay, this person deposited 20 Ethereum. And another person who is this one, this person is also depositing the amount. So he is depositing 5 Ether. This person deposited 5 Ether. Okay, it is deposited. Now it is total 25 Ethereum in this smart contract. In this smart contract, there is 25 Ethereum is there. Okay, that is our smart contract, deposit fund, the smart contract. Actually, this smart contract is highly vulnerable for the reentry attack, and this is the smart contract created by the attacker. Attacker created this one. First of all, this smart con, I'm going to deploy this one. Okay, this person going to deploy. Okay, before going to do, I can have. Okay, I'm defining one more function over there. Function. Okay, I'm going to deploy this one. we're going to deploy which smart contract attack. Deploy. So the attacker smart contract is deployed. Attacker smart contract is deployed. And one more thing I am going to do is here deposit to Ethereum. I am depositing to attacker smart contract. To Ethereum, I am depositing. Okay, now attacker smart contract having enough Ethereum and deposit this our actual banking smart contract or something already having 25 Ethereum. It is deposited by some public persons 25 Ethereum over here, and attacker created this smart contract. And now what he is doing is he is calling this function attack. Okay, attack function must okay, he is calling this function attack function. One Ethereum I am transferring. Now it is transferred. Now it is transferred. Now I have called this attack function. What happens is what will happen is it is supposed to deposit fund balance should be debited. It is going to execute. Okay, it is supposed to debit all the monies from that account. Okay, one Ethereum. We've called okay something I missed. Oh, receive function. Because of receive function, I think. It may be because of this receive function. Okay, I am executing now 25 Ethereum over here. Now I am attacking. See what happened. Previously there is 25 Ethereum was there. Now all the Ethereum is credited to the attacker smart contract. Previously 25 Ethereum was there. Now it is 0. All the money I have collected. The attacker is attacked the smart contract and collected all money in the deposit fund smart contract. It is because this deposit fund smart contract is highly vulnerable and we can use this type of attack. This attack is called a re-intrinsic attack. This attack is called a re-intrinsic attack. So your smart contract should be while you are writing the smart contract, it should be secure. Otherwise, this type of problem may happen. Okay, this type of problems may happen. This is called a re-intrinsic attack. It is working because we are calling, while calling this attack function, what will happen is it will deposit one Ethereum. The attacker function, attacker smart contract deposit one, this function will call and he deposited one Ethereum. And similar after he is withdrawing it. What happened when he withdraw? When he call this withdraw function, it will retrieve the balance. Balance should be greater than 0. We already invested one Ethereum, so it is one Ethereum is there. Balance is greater than 0. Then it is calling to the it is transferring the balance, that is one Ethereum we already invested. So one Ethereum to the smart contract, to the attacker. Attacker already invested one Ethereum and that Ethereum is transferring, okay, to the returning to the attacker smart contract. by calling this function mst.sender.call by value is balanced. And while calling this one, what will happen is it will automatically execute this fallback function as well. While calling this fallback function, what will happen? It is again calling this withdraw function. Again calling this withdraw function. In the withdraw function, it is again calling. Again calling means what will happen? Get the balance. That is still it is one itself, because we are not setting before setting this balance equal to 0. Before setting the balance of that center is equal to 0, again calling this one, again calling this function. So now also the balance is 1. So he is transferring 1 Ethereum. This deposit fund smart contract transferring 1 Ethereum to the attacker. Now attacker receives this 1 Ethereum, again to execute this fallback function, again calling this withdraw function. In the withdraw function, it is calling and to fetch the balance. Now also the balance is 1. Now because we are not reached over here. Before reaching over here, the withdraw function is calling again and again until the balance equal to 0. So this is type of attack is called the re-intrinsic attack. So while seeing this one, you may see that the smart contract is secure, but now this smart contract is highly vulnerable. So before you write the smart contract, make ensure that this type of attacks is also there. It is called a re-intrinsic attack. Re-intrinsic attack.